Good afternoon. My name is Courtney Kennedy, and I work for OPBD. And I get the pleasure of being with you for 2 sessions to discuss SPP, or the Southwest Power Pool. So first off, we'll hear from Cathey, who I'll introduce shortly, and how SPP is changing. And then we'll give you a nice long break, and then we'll come back and we'll talk about SPP more locally here in the state of Nebraska. So I will introduce Cathey, standing here to my right, Manager for Reliability Planning and SEAMS with the Southwest Power Pool. Cathey is a 16-year veteran of the power industry and is a subject matter expert for energy markets, transmission planning, and grid operations. He was a leader in the SPP integrated marketplace implementation from the cost-benefit study through go live and support and maintenance after go live. He has previously operated in a balancing authority with reliability coordination, tariff and scheduling, and transmission operation functions. He has a Bachelor of Science in Electrical Engineering from Louisiana State University, an MBA from the University of Arkansas at Little Rock, and has held a professional engineering licensure for the last 11 years. Lately, he has primarily been focused on incorporating the vast amount of renewables SPP has both reliably and economically. And with that, I'll turn it over to Cathey.
As Courtney mentioned, actually my title changed. A lot changed within the last 2 weeks that I sent this deck. So my title changed and a lot of the wind statistics changed, which was interesting. It seems like as soon as we set a wind record and we publish these things, we go to a conference, and by the time we actually get to the conference to present the updated data, the wind statistics have already changed. It's happening that fast. So I am the manager of transmission planning and SEAMS. So what that means is that I'm responsible for an annual process to where we assess the grid 2, 5, and 10 years out every year. And we look to see what transmission we need to build for a 14-state region. Also, SEAMS work, we actually have a vast SEAM across. We actually have all the DC lines with ERCOT, all the DC lines with the Western Interconnect, and we have over 300 EHV and HV tie lines with the rest of the Eastern Interconnect from an SPP region. So I do want to spend a couple of minutes just talking about SPP as an RTO. The description of the presentation I'm supposed to give is SPP 101. So I want to make sure we kind of level set what SPP is because it's not a traditional utility. And so if you've never heard of an RTO, or I mentioned it was mentioned earlier a variety of times from the CEO panel, from some of the other presenters earlier this morning, what SPP is. And SPP is this kind of company that is responsible for setting reserve margins and so forth. So I'm going to spend a few minutes on that, and then we'll talk about wind and solar, because that's kind of the point of this conference. Well, I don't know why I put the order this way, but bear with me. So this is a trend of the evolving generation mix. The 2 key things that I'd like you to take away is the amount of coal that we had back in 2011. This is annual percentage serving load, and obviously coal is dropping. Gas has remained about the same, and wind is increasing. So wind is effectively displacing coal across all or parts of 14 states. So a couple of things about this slide. One is the red, that is Southwest Power Pool's territory. It is all or parts of 14 states. Again, if you're not directly in this business, the United States is broken up into 3 interconnects. They all operate under 60 hertz, so even the receptacle in the wall is operating under a frequency of 60 hertz. But the frequency in Lincoln is different than the frequency of all of this territory and all of this territory. Texas has to be their own thing, it's Texas. So they operate under their. It's a blessing or a curse. I mean, they can do some things, but they also can't lean on their neighbors from a synchronous resource or frequency perspective. But we are, in Lincoln, is part of the Eastern Interconnect, which has been known as the largest human machine. Because if you take into account all of the different resources for all of the Eastern Interconnect, all the way up through Maine and down to Florida, we are all connected and run at the same, or we target the same 60 hertz. Obviously, that floats differently than the West. Another thing to look at is just our footprint. So we have a large footprint. The seam goes all the way from Canada down into Louisiana and Texas. We have two ties with ERCOT, which is the RTO of the Texas region. And of course, we have Nebraska, so that's the reason why I'm up here. Another thing to look at from this slide is the wind and solar. This is a few years old, but it's basically a nice profile to say, okay, you know, some people have said SPP is the Saudi Arabia of wind, and it's true. We have very good wind profiles, and if you look, the footprint, this blue region from this NREL data is effectively SPP, and then there's this yellow region, which is the irradiance levels of solar and kind of the better solar profile across the United States. And of course, we have a good chunk of green, so we have a good solar and wind profile. We do have one single tie with Canada, which is interesting. We have an international seam, and so we work through transmission plans with the Canadian government and trying to figure out if there's additional upgrades and transmission that we can do with them. Okay, so let's go into, well, before I go into wind, SPP, as a regional transmission organization, we are a servicing agency. Just like if you boil down what a business is, you either make a widget or you are a servicing agency. And so we don't own anything. SPP doesn't own any transmission. We don't own any generation. Why I really like my job is I get to be more agnostic to what's going on the footprint. In other words, if NPPD wants to build, let's say they want to build coal, we say, okay, well, let's try to make that happen. If OPPD wants to build batteries, we try to figure that out. So I'm fuel type agnostic. It's more pure physics and regulatory and trying to do the right thing for the right reason. So SPP is a membership organization. We have 650 employees out of Little Rock. We perform a variety of functions, and primarily it's an economies of scale thing. We have over 90 members, and they span from traditional vertically integrated utilities. We also have IPPs. We have a couple of residential members, so we have a variety of types of sectors that are members of SPP. And really, what we do is we're not for profit, so we try to do reliability coordination. We do single balancing authority, so this is an entire balancing authority that we operate to. We also do transmission planning. We do transmission service provider, so we operate a tariff. So that means that anybody who invests in transmission, we assess the system for the use of the transmission, and then we compensate those transmission owners for the use of those systems. So that's a transmission settlements market. We operate, since 2014, we've been operating a wholesale energy market. Since 2007, we've been operating an energy imbalance services market. So we have a lot of history there in terms of wholesale markets, reliability coordination, and transmission settlements. And it takes around 600 plus employees to kind of operate all of that. So this is our wind profile, and this is, again, the same region. In 2001, we had negligible amount of wind. I joined SPP from Entergy back in 2006, and I can recall that wind was a nuisance. It was 1,500 megawatts maybe, and I was in operations, so I was working with the reliability coordinators. We were trying to figure out congestion management, and at the time it was some of the older turbines, mostly in New Mexico and Oklahoma and Texas. And it was more just, let's just ignore that. That's 1,500, we'll just ignore what they just, this wind, we have a little display and we just ignore it. It started increasing, right? And a lot of you in the room experienced that in terms of your business. In 2007, we started the energy imbalance market. In 2009, as you can see, wind picked up and it got closer and closer to 5 gigs installed across the footprint. We started implementing some wind studies. And at that time, we were concerned about 40% wind penetration. We were saying, okay, what will happen to the grid at 40%? So we even worked with a third-party consultant to figure out what the impacts are of the system. Come to find out, we were fine. We were really nervous at 40%. Now we are exceeding 60% on a frequent basis. So what we were nervous about 10 years ago, we're hitting, it's just a normal day. We're constantly over 50% across the footprint wind serving load. So the question now is, what's next? Can we meet 80%? Can we meet 90%? What is the next level? So coming from an operational background, I always feel like in order to be an effective grid operator, you have to be a little bit nervous. You have to ask questions, and you have to constantly think, what if? What will happen? Because we are paving new ground. I mean, it's a pretty exciting industry, and it's no longer, can you ask Denmark how did they get to 100% renewables? Can you ask California about their solar concerns? Yes, you can learn from them. You can learn from ERCOT. ERCOT, Texas has a lot of wind, but SPP is really paving new ground every single day. And so what that means is it's a blessing or a curse. You kind of say, okay, we're doing very well. Nebraska is doing very well in incorporating wind, and now the next phase is solar. But now it's no longer asking people, even in the world, we're talking New Zealand, we're talking Hawaii, they're asking us what our opinion is and how we operate with the amount of wind that we actually have. So in order to do that, we're put in the spotlight to say, okay, we need to not run off a cliff. We need to make sure that we're very reliable and always ask the important questions of what's the next challenge. And as you can see, we've gotten up to past 20 gigs of installed wind across the footprint. In fact, and this is the slide that's outdated, I gave it to Courtney just 2 weeks ago, maybe. We are over 22 gigs of 22,069 is how much we have installed of wind across 14 states and operating over 11,000 individual turbines. So approximately about 2 megawatts a turbine on average. Of course, if you look at the installed, there's older technology, and then there's newer technology, kind of in a big chunk of newer technology. So the turbines have obviously gotten a lot more efficient. We have 9,000 megawatts of unbuilt wind. One of the common questions that I get at these things is, how much wind do you think will be built? I don't know. That's a very important question, but who knows? Now, what I can say is that there is a process. We have the generation interconnection process. We have a lot of wind in the queue, and we're processing through that. Now, what has signed GIAs, that means that they have committed to certain financial obligations to be able to connect to the grid. We have 9,000 megawatts of that. So some portion of this is going to be built on top of the 22 gigs. I believe it was mentioned earlier about negative pricing. Negative pricing is something of a phenomenon. If you guys ever took Econ 101 or remember supply and demand curves, all the wholesale markets are linear based. It's based on the next megawatt. It's based on a supply and demand curve that sets the price. So you don't even have to run Excel spreadsheet or whatever. You can design your own market and say, okay, if you have a $9 nuclear resource and a $20 coal resource and a $23 gas resource, and you just stack those generations from an offer curve perspective, what's the next megawatt of load coming from? Maybe it's gas. Well, that sets the $25 price. That's kind of how traditional markets work, right? It's how most of capitalist society works, that's what sets the price. Well, when you introduce wind and solar that have a zero fuel cost, then it causes, when you have too much of that on the system and you don't have enough load, then what happens is the price tanks and it gets actually negative. So we've had, I had the engineers pull this last night. We've had 318 hours of negative pricing this year. And so that's an interesting statistic. It might not sound like a lot, but it shows, it kind of illustrates what wind and solar is doing to traditional wholesale markets. It's kind of interesting. 50 gigs of wind installed across the footprint, and 23 is what we're forecasting by 2020. That's where we're at. It's kind of conservative. Nebraska joined in 2009, so our footprint expanded. 2015, the integrated system joined, which was the Dakotas. This is illustrating just how much wind we had built across each year. Okay, so I'm not going to, maybe y'all saw that. Hopefully you didn't read really fast. I shouldn't have done that. Here's a test. It's a question. We have over 22 gigs of wind installed in the footprint. And most people say, okay, wind is regionally diverse, and it is. You know, SPP, it's all over the place. We have some in the Dakotas, we have some in New Mexico, we have some in Oklahoma, Nebraska, obviously. Can anyone tell me what the minimum output of 11,000 turbines across 14 states was in the last year? Speak up. 0. It was a little bit more than 0. One more.
147.
100. Yes, someone read the slide.
I saw your presentation 2 weeks ago.
Okay. Yeah, there it is. Okay. This is important, okay? This is very important for what we're actually trying to do, right? This is what I like about my job, is trying to incorporate wind, is trying to incorporate solar, and we're talking vast amounts of solar. We're talking 20 gigs of solar across 14 states. We have almost 7 gigs of batteries in our queue. That's very disruptive technology. It's almost like Uber to taxi cabs. It's extremely disruptive because a battery can operate as a transmission asset, it can operate as a generator asset, it can be a load. It's flexible and cool, but it's kind of disruptive to what we're doing. But that's what makes my job interesting, is trying to figure out how to do that. And with this number, it's a little bit scary, right? Because wind is a good asset. It is a good asset, but there's pros and cons. And something that we've experienced at SPP, given the amount of wind that we actually have, we have had less than 0.4% capacity factor across 14 states. So typically our capacity factor is very good. It's over 20%, and in a lot of cases it's over 40%, depending on which farm you're looking at. So we do have really good wind, but there's instances where we don't. And it's those instances that we don't that we need to be prepared for and figure out, how are we going to replace it? Are we going to replace it with more wind? Is solar complementary? Yeah, solar is complementary during the day. And then at night, how do we value the flexible resources that we need that's non-solar? Is it gas? Is it hydro? Is it batteries? I mean, batteries can be a very good asset to be able to store the excess power that we actually have that's causing those negative prices, and then discharge in the hours that we don't have wind and it's at night. So this was one of those 24-hour periods where we actually had, this was last December, we had 16,000 megawatts serving almost half of our load. And within 24 hours, this is 48% of wind, 24 hours later is 17% of wind. In this case, coal and gas basically backed it up. And so I'm not here to say we need to keep coal and gas around, but we're in a transitionary period. So a lot of questions we have is, can we see a 100% renewable future? Right now, no. Right now, what we do to operate the amount of wind we have, we don't have any solar, so I just want to make sure. We have 215 megawatts of wholesale solar. We have a lot coming, and that's going to be a very big, nice challenge for us to incorporate all of that solar. But wind is really the big ticket item for SPP, and it's maintaining that reliability of being able to incorporate and embrace the wind, and we're in a transitionary period. So I can tell you what we do. At SPP, we look constantly at forecasting, and we constantly look at variability. We look at where the wind is going, and we try to predict when it won't be there. And then we're always looking at how much gas. It's primarily gas. We're looking, because any given operating hour, we have around 6 to 11 gigawatts of controllable 1-hour starts of gas. That's a large amount of gas, and we always have that ability to start up those 1-hour gas turbines to be able to back up what we lose in wind. And that is primarily how we're able to operate the amount of wind that we actually have. I think this was referenced in the CEO panel. We lost 13.3 gigs in 22 hours. I really need to retool this slide so that it's more illustrative of what an operator sees. Because right about here, they thought the line was going this way. Okay? So just picture that. You're sitting, your job is balancing authority for SPP. Forget transmission congestion. Let's just think about just supply and demand. That's all you're trying to do, is meet supply with demand. That's it. So you're just operating the balancing authority, and you think the wind forecast is going this way, and everything that we see, all the weather patterns that we see, we run 10 different weather models. We actually have 3 different weather vendors. We have multiple load forecast vendors. We have a wind forecast vendor. So we have a lot of different, not just SPP staff, but we have a lot of other staff that are feeding us inputs to say, okay, will this happen? And no one told us this was happening. And so when it started happening, you just walk through it, right? These are a series of hours. These are hour marks, right? So when it started happening right here, what do? Tell me what you do if you're an operator. Call your boss. Dispatch whatever you have for reserve. So you do that. Do you dispatch 4-hour resources, the resources that can come on in 4 hours? Just come on, answer. No, probably 1 hour, right? You want to start up your, but then okay, you start up everything that you have this 1 hour, and then okay, it keeps dropping. You're now here, and you're an operator. It's 1 hour later. What do you do then? Again, you don't know this. This does not exist in your brain. It's not in your displays. It's still constantly saying this. What do you do at this point? You turn on everything. You turn on everything. But here's the thing, and this is why forecasting is so important in our business. It's so important for solar. It's so important for wind. And I never thought that I would even be interested in weather, but meteorology is actually kind of fun, and it very much feeds into what we do now. It didn't 20 years ago, but it does now, other than load forecasting maybe. But so some of these 4-hour starts and some of these 6-hour starts, these longer start resources are actually pretty economic, but they take a long time to start, right? And so you have to know that you're going to need that on for a period of time to try to optimize whether or not you should start it, right? It's expensive to start these resources, but once they're online, they're kind of cheap to stay online. So what you have to do is you have to be able to somehow predict that this is even going to happen. And when every input coming into you is saying it's not going to happen, and you're an operator, are you going to hit the button? Each button click is $40,000, $50,000, $100,000 startup costs. It's a lot of money, and they know that at SPP. These operators are very responsible. But how do you do that? Because every time you're costing everyone in the room, you're costing money. It does impact the wholesale market every time you start up a resource. Anyway, so this is a challenge. And so this is another kind of illustrative piece of wind. This is the amount of capacity we had on that day. We actually have pretty decent wind, 62.7% of wind, which this is an old statistic. I actually have an updated one. And then coal is pretty variable, gas is pretty variable. We have some nuke and some hydro. Okay. I'm going to just spend a second on this slide. It's kind of difficult to read, but the point of this slide is we try to predict how much wind is going to be built in the future. And to me, do y'all know those like horses at the carnival when you go, or like the state fair, and you spray the little gun and the horses kind of jump back and forth? Do y'all know what I'm talking about? That game? I don't even know what the game's called. I kind of visualize that horse game in terms of transmission and wind build out. Do we build the transmission and then the wind comes? Do we build the wind and then the transmission comes? It's trying to figure out what is optimal for the system, because we could build out a bunch of transmission. Something Ron Thompson mentioned to me right at the break is microgrids and distributed energy resources. And do we need, if there's a large investment in local generation, then do you need to build out the transmission in order to access generation that's really far away? I mean, these are all really good questions, and that's really what we're trying to do in transmission planning. So the point of this slide is these are our 10-year projections, okay? And we have already exceeded, this is where we're at, and we have exceeded all 3 of our 10-year projections in a couple of years. So when we talk about our long-term transmission plan, we are extremely conservative. We have been in how much wind we actually assume in the next transmission plan. So don't be surprised when we still have congestion in order to access that transmission, that wind, because when we were predicting the amount of wind that was going to be built out, we were conservative for at least 8 of the 10 years. This is illustrative of the generation retirements that we assume in our latest long-term transmission plan. So you can see gas and coal, and obviously it's increasing in 2024 and 2029. We have two different futures that we look at that tries to predict what's actually going to happen over the system. It's very challenging because you're talking about millions, potentially billions of dollars that need to be invested, and we're in kind of a mode to where it's always been difficult, I think, to pull the trigger on millions of dollars of transmission. If you're a regulator, if you're part of that approval process, if you're part of the board of OPBD or MPBD, I'm sure it's extremely stressful to be able to take all these inputs and pull the trigger on a $12 million project. Well, then that was probably stressful 10, 15 years ago, but now you introduce a lot more variables in the equation. And we still need to invest in transmission, but it's questionable or that much more so on the variability of whether or not we get a return on all that investment. So that's a challenge. This is our queue. As you can see, this is our latest queue, just visually. And I just want to pop this. One thing to glean from it is just it's all over the place, right? We have wind, which is the green. We have over 50 gigs of wind all over the place. Solar sites are the yellow. But then I also wanted to highlight the batteries. So the latest numbers are 6,800 megawatts, so just under 7 gigawatts of batteries. And in Nebraska, you have a ton of blue as well. So batteries are kind of being peppered across most states. I'm kind of excited about batteries. I think they're a challenge to be able to change all of our policies, our tools, our processes. But having 6 gigs of batteries that maybe are 4-hour batteries is going to be a very good grid operationals tool for us, just not even locally, but be able to shift power back and forth. It would be very valuable. Okay, so this is the queue, just shy of 50 gigs of wind, almost 30 gigs of solar, and 6,800 megawatts of batteries. All of that is technology that's in your pocket. It's all lithium ion. I know there's flow batteries and all kinds of other technology, but what this entire number is lithium ion technology. So they're all the same. Everybody, all battery developers have a little bit different chemistry and that kind of thing. But this is a pretty interesting challenge. And I don't know if going forward, the Nebraska Wind and Solar Conference is going to be talking about Nebraska Wind and Solar and Battery Conference. But that is probably the next stage. For me, I feel like solar is going to be our next challenge for SPP, probably for the next 5 years, and then batteries are going to be the next challenge. This is a kind of an overview of the RTOs. PJM, Philadelphia, New Jersey, Maryland, ERCOT's Texas, MISO's right next door to SPP, California's California, SPP, New England, and New York. Just kind of saying, we have majority of the renewable resources, 84% that's in our queue that's coming. But the thing to glean from this is that it's happening to the entire United States, and you guys know this, but it's pretty clear that there's a push for renewables across all RTOs. So I wanted to spend just a minute on, do I have enough time? Just a minute on storage for a second, because storage is going to be pretty disruptive. Right now, we have the ability to incorporate storage. So we meet FERC compliance. If you have a battery in the queue, we're trying to process that as a generation and a load asset so that we can assess the impacts to the transmission grid. We can get you interconnected. And then we're working on a market participation model, but you can actually participate in 5 products today in our wholesale market. So if you qualify, which means when I say qualify, you have to be able to discharge at a consistent rate for over an hour, because that's how our hourly day-ahead market works. You can participate in energy regulation up, regulation down, spending and supplementary resources or products. But we also see kind of a large push for where we need to go in the future, and that's additional market products. Right now, I mentioned 6 to 11 gigs of gas. I'm not picking on the gas. It could be batteries. Something needs to be able to back wind and solar when wind and solar is not there, and it could be batteries. So we'd like to look at capacity accreditation for batteries. We'd like to look at long-term capacity, maybe a capacity attribute market. So it's not really the capacity that we need. It's more, do we have a certain amount of flexible resources to be able to bounce against the renewables when the renewables are not available? Ramping is another concern. And when I say ramping, the concern that I have, going back to the 13.3 gigs that we lost, we need flexible resources that are longer duration, 1 hour starts, 2 hour starts. It's not really the 1 minute loss of resources we need. It's not the quick start resources. People say, oh, you need quick starts for wind. Actually, that's the good thing about our footprint is we are regionally diverse. So when a low pressure system comes in off the plains, and basically what happens is your prevailing winds turn up. So it's a three-dimensional problem at the 80 meter mark. So wind is blowing, and it's great meter per second speed, and then a low pressure system comes through over a massive 400 megawatt wind farm, and every single turbine, the wind speeds turn up, and they move perpendicular upwards. And so it kills the turbine. And so the turbine dies, and then all of a sudden every single turbine it ends up hitting zero over a series of time, and that's what you saw with the 13.3 gigawatts of loss, is this low pressure system that kind of moves in. And if you recall, you probably look at, I don't really watch the news that much anymore, but if you look at the weather, when the weatherman was talking about it and there's a big L and it moves around, well, if you can imagine going back, the challenges that we have, let's say we have a cluster of wind in here. All it takes is a low pressure system to move 50 miles one way, and all of a sudden our wind forecast is, you might as well throw it in the garbage. That's how sensitive our footprint is to the weather. It's not just temperature and the things that you would traditionally think. And so by doing that, we really need more flexibility on the system. And that's in terms of ramping and 1 hour capacity. So that's what we're working on. We're working on a ramp product. We're also working on a 1 hour capacity product. That is to put some types of value to those that want to bring to the market to be able to bounce against when the wind and solar is not here. Transmission solution. So this was our first year to actually get batteries submitted as a transmission solution. That's kind of interesting to me. Because we've never really, in the tariff it says at SPP that we must assess all non-transmission solutions that are submitted through our competitive process through FERC Order 1000. And that is something that's been in place for a long time, but no one's going to build a gas plant for a transmission problem. It's just not going to happen. They might consider it in their overall business case and so forth, but it's not the sole reason. But batteries are getting cost competitive, and it's getting to the point where maybe in the next few cycles, we might actually see a battery selected as a transmission solution. Why I'm even mentioning that to y'all is it does change the landscape of how transmission even works. It changes how the market works because it is injecting megawatts. A transmission line or a transformer does not inject megawatts. And so it really is a disruptive technology, but I think that we could probably make it work. Frequency response. You might be hearing this a little bit. So I mentioned 60 hertz, right? So just a frequency 101, we target 60 hertz. It was decided many, many years ago. That's what we would target, and that's what a lot of electronics are designed around in the United States. I think Europe runs it at 50 hertz, so it doesn't necessarily, there's nothing magical about 60 hertz. It's just that's what the standard is designed on based on the cycles per second that we actually need from an AC interconnected system. But for frequency response, you hear, oh, renewables, they don't bring frequency response. And they lower frequency response. Actually, what we've seen over the last 20 years is wholesale markets. We did this to ourselves. So every wholesale market that got stood up, you have 2001, you had PJM, this very powerful, very big market got stood up in 2001. 2006, MISO got stood up with a wholesale market. 2014, SPP was stood up. Each wholesale market, what did we do? Can anybody tell me what we did with generation when we stood up a wholesale market? Where was the main benefit of consolidating 16 balancing authorities with SPP? Does anybody know? We took off 5,000 megawatts of traditional conventional resources. So before, you look at Nebraska, before 2014, you had NPPD, OPPD, and LES. And they had to bring to the table online capacity for their obligations. All we did is just circle the whole footprint and said, no, you don't have to individually. We're going to optimize that. So day one of our wholesale market, March 2014, we took off 5,000 megawatts of installed capacity, which is basically spinning mass of coal and gas online. And there's your direct benefit. You have other individual benefits from the wholesale market. But if you do that across the entire massive, largest human machine in the world, with PJM in 01 and MISO in 06, I forgot what year ISO New England and New York ISO, but if you combine all of the markets, we basically did our to ourselves without wind and solar. Now, wind and solar don't necessarily help the problem, but we reduced our own frequency response because we don't have the spinning mass on the system that we naturally had before wholesale markets. I mention all that to say frequency response is something that we're also looking into to be able to say is another product that wind and solar can actually provide something to. They would just have to hold back their generation and then output further whenever they're called upon for frequency response. Batteries as well. Hybrid coupling, so 2/3 of that number, the 6,800 megawatts of batteries, is coupled with something. I was actually surprised that people are investing in batteries just without solar in investment tax credits, but they are. So 1/3 of our queue is just standalone batteries, and 2/3 are connected to either wind or solar. Maybe at this point, open up for questions. So the question was, can you explain the transmission solution? So picture a small city, okay? Let's say a small city in Nebraska. And we run a model, right? And it's just physics-based, it's mathematical-based, and we run a model and we try to predict overloads. And let's say it's a 115 line overload. So it's a 115 kV overload. Just to give you some numbers, so let's say the rating of that line is 100 megawatts, and we're predicting a certain load growth in that small town that exceeds the rating of that line by maybe 5 megawatts, right? So we're predicting in 2 years' time that rating of that line will be or the flow on that line will be 105. So you're at 105% loaded of a 100 megawatt line. Traditionally, you'd build another line, or you'd build generation, whatever. You'd build something in there to be able to mitigate that transmission line overload. What a battery can do is you put the battery in the load where the load's sited, and whenever that loading actually occurs in the city itself, the battery can discharge to feed that load, thereby not having excess power flow across the transmission line. So the problem with that is predicting. We don't even have the capability right now. Well, I mean, we do from an economic model perspective, but we don't really know how long that 105 megawatt loaded period is going to be. Is it a 5-hour problem? Is it a 6-hour problem? Well, if you have a 4-hour battery and you just selected it as a transmission solution for a 6-hour problem, you've got a problem, because in 2 years' time you're going to run out. You're basically, your phone's going to die before you actually need it for the full time. You know, so. Question?
Yeah, comment or question. So comment, I liked your slide that showed that wind is displacing coal in SPP. Mm-hmm. My comment is in Nebraska, that's not true. Coal is about the same amount of use as it was 10 years ago.
Yeah. But I have an answer for that.
That's not my question, but go ahead.
Yeah. So Nebraska, when they join, and unfortunately I removed that slide, but when they join, all of Nebraska, it's a net exporter. And so what ends up happening is, and it kind of skews, from your perspective, and I fully appreciate that, but what it does is when you look at 2009 to 2019, the rest of the footprint use that excess coal. So you might see that coal is the same, but what is actually happening is you would have reduced your coal consumption, but the overall market needed excess power, or more power, so basically it raised the capacity. It's almost like a timeline skew, and you say, okay, what alternate reality would have happened had you not joined SPP, and it would have reduced your coal consumption in the Nebraska. But at the same token, you probably wouldn't have been able to operate with the high levels of wind that you have either. So it's kind of an interesting kind of what if scenario. But that's exactly why the coal usage maintained.
Yeah, it is interesting. We're a net exporter of electricity, not an end.
Yes. Yeah.
So my question was in the 13.3 gigawatts in the 22 hours, SPP asks something of utilities, how to respond to that.
Yeah.
Among them, maybe firing up some gas-fired units.
Yeah.
Tying that back to your other point that investments in gas are not really happening now. What's your prediction for if we were to invest in gas today, its need in, say, 15 years?
What's my prediction? We will have to build a lot more batteries if we're going to try to operate with the amount of wind and solar and batteries that we have, if coal continues to retire and our gas also retires. I'd say in the next 15 years, my prediction is we'll still have gas, but we need to value it a little bit differently than what we do today, because we basically value it in SPP. And what I mean by that is we're not actually putting a financial number on it. We're not actually paying for this. We just happen to have a lot of it's in Oklahoma, but we just happen to have a lot of gas in the footprint, and we use it whenever wind is not there. And even with the amount of solar that we have, I've looked at the wind profiles over 4 years' time, and there are a lot of times where we absolutely need something to replace it. And it's on the order of 5 to 10 gigawatts. So unless we overbuild batteries and save them for those time frames, we're going to have to do something with the amount of flexible gas that we have. So it'll be interesting.
Thank you.
Yep.
Casey, this may be a speculative question, but I'm going to ask it anyway. Did you all participate in the NRO series, the interconnection study?
Yes.
Any idea what might come out of that thing? Because I know they haven't released it.
So I'm in charge of SEAMS, transmission as well, and I can say that, well, how do I put this? The optimization of the grid is more of a human barrier than a physical engineering barrier. And there's reasons for that. I don't want to come across negative, but it's almost the reason why the federal government came up with the highway program in the 50s. And I'm not saying that that's what we do, but everyone has their tariff. And in order to build transmission, even within our own, we have a single tariff at SPP, and it's still difficult to build transmission. So the likelihood of building a massive scale, given the current regulatory environment that we have, I think is difficult to overcome. So I think the results might be positive, but I think there's going to have to be a heavy hand in trying to understand and move forward. And that's really the states and the federal government working together to try to figure out what to do with the results. Yeah. I mean, we might get there, but it's probably not going to be in 5 to 10 years. It might be, 20 years from now.
This morning, I think it was the Toronto person was asked, or it was a general panel question to identify issues for Nebraska developers. And the response was that there was a logjam with the SPP in projecting in their projects the interconnection on saying who can or cannot connect. And there were about 90 megawatts lined up.
Yeah. So, okay, so the generation interconnection has been a hot topic at SPP. And I kind of mentioned it briefly, but it was never designed to handle an inrush of renewables. It just wasn't. And so we can look at it and say, oh, it's SPP, it's this, but you have to look at the history and you say, okay, this stuff was designed in the late 90s. And in the late 90s, the tariff language associated with the way in which we calculate power flows, and we run queues and cluster studies to be able to incorporate additional generation into the transmission grid, was all designed on incremental gas mostly, or coal or hydro or whatever. But that was 20 years ago. Now fast forward to the last maybe 5 years, we're having unprecedented amount of wind and solar. I mean, if you look, our peak is 50,622 megawatts. That's our peak level of load. And we have more renewables in our queue than what we have total peak load. and people say, okay, you can export it. You can export it to MISO, you can export it to Atlanta. That's not how it works. It just it's not how it works. We cannot speculatively we can't displace Atlanta load or generation in our queue. We have to be able to realistically say, okay, if this wind farm is going to connect in Nebraska, then where is it being served? And we can't speculate that it's going to be all exported. So we can do some exports, but we just can't physically get all that in. So what we're trying to do is two efforts. One is starting in January 2020. It's already passed the approval process by the stakeholders, and that is a three-stage process. And in a nutshell, what that is trying to put in cost barriers or financial barriers, because we've actually seen a large part of the amount that's in our queue. I want to say a good chunk of our queue is they're using us as almost a consultant firm. So some of these wind developers are coming and they're saying, hey, I'm going to build this wind, but they're not really serious about it. They just want to see what it takes to incrementally, it's $7 million worth of upgrades that you need to be able to incorporate the wind. So they're using us, almost abusing us in terms of just using us as a consultant firm, whereas they should be doing that and then come in when they're serious about interconnecting. So we're trying to build in some financial barriers to say, okay, if you're serious, you have to pay us, and then that money doesn't go to me or staff. It goes towards your interconnection agreement and those upgrades, but it puts some financial obligation in terms of, and so hopefully that filters out some of the noise that's happening. And then also we're working on another effort that's not effective yet, which is being discussed. NPPD, OPPD, and LES are involved in that. Is putting something called ERIS and NRES, our network resources and our energy resources, and putting more emphasis on those resources that are going to come and stay, and they're not speculative energy-only wind farms. And so what we're trying to do is change the parameters so that those wind farms that are not really have a PPA, they don't really have an obligation to serve load, they're just connecting, then they have more obligation to build transmission. And that means ultimately, they might whittle out a little bit because their overall business case is a little bit not as solid. And so, from our perspective, we're not doing it, to be mean or anything. We're just saying, look, if you're going to connect, you have to put some more obligation on building out the transmission system, and then hopefully that'll filter out the ones that are not so serious about being here for the long term. So, yeah, one more question. Yeah.
I just was curious about your thoughts on the SPP expansion.
The SPP expansion? So are you talking about the West? Okay, so I can go back maybe just a visual real quick, but we are effective December 3rd of this year, we will be the reliability coordinator for a good chunk of the Western Interconnect, all the way to Tucson Energy, and all our parts of Wyoming and Colorado. Peak Reliability is the reliability coordinator for the West right now, and they close their doors at the end of the year. California is going to be, CalISO is going to be the RC footprint, or RC for the remainder part of the West. We also have under contract what's called unscheduled flow mitigation. We handle all the phase shifters in the West. And we also have a commitment from WAPA and Tri-State and Basin for energy imbalance services in the West. That's two balancing authorities in Wyoming and Colorado. And so that's where we're at right now is contract services. They're not full members of SPP, but we have been very transparent that this is basically, that's what contract services is getting a taste of what we can do. And then hopefully the expansion of the West will allow, and why it matters to Nebraska is it does help on the West side because we can actually optimize in the wholesale market the DC power. So if we can't dump enough wind and solar in the load centers of SPP, we could actually export it to the West as well. And also there's potential transmission expansion. There's even consideration of removing the transmission line, the DC lines and moving the footprint, which is a much bigger, longer effort. But there's potentially a lot of good things to come from the West expansion. Not to mention that the fees of SPP reduce for Nebraska if more load is in SPP. Thank you.
All right, let's give it up for Casey.